Alrighty. Hello, everybody, and welcome to the stream. I hope everybody is doing well today. We're going to pick up where we left off yesterday with our hot reloading stuff. I did get some stuff done off camera, so we're going to go over that really quickly. It's not all that much. And we're going to, I think, tie up hot reloading in general today and move on, hopefully, getting our shader system at least done, at least compiling, right? I'm sure there's going to be some debugging and stuff we're going to have to do once we're up and running, but yeah, that's kind of the goal for tonight. And then from there, we'll probably start switching back to the material system and handling all the stuff that we need to handle from there. But before we do any of that, I do want to just take a quick second and thank the supporters of our channel, beginning with our elite partner, Javier Alazaran. I'd also like to thank the partners for Furkan Tokan, Gerboles Inc., and Matt Osgard. So the elite partner is the highest tier of subscription, and the partners are right underneath of that over on YouTube memberships and Patreon. And then we have the other supporters here listed on the screen are a combination of the other tiers of support on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for your support. It's greatly appreciated, and it helps me cover costs associated with the project, such as hosting, licensing fees for software that I use, things of that nature. So thank you very much for the support on there. And of course, this project would not be what it is without each and every one of you viewers, whether you're catching the VOD after the fact or you guys are live here with me on YouTube or Twitch. We simulcast to both. This is an interactive stream, so if you guys have any questions or comments, just want to say hi or talk about something, feel free to jump in the chat and we'll do that. All right, so with all that out of the way, we're going to jump back into hot reloading, and I actually think that I've solved most of it off camera. We were like 90% of the way there last night, so I think I've actually got it locked down to where we needed to get it. Smudge, it's good to see you. Hello. And Arvis, good to see you as well. I hope you guys are doing all right. All right, so where we left off last night, there was a bunch of stuff in the shader system having to do with hot reloading and whatnot. And actually, we've actually removed a lot of code out of the shader system itself. So everything that had to do with in terms of like copying over all the shader data and all that stuff from the resource and whatnot, and processing all the various stages and trying to load additional assets. All that stuff has actually been moved out of here, and we'll go over that in a second. But I've decided to switch up the way that that the shader system actually handles this stuff. And so what we're actually going to switch to is something a little bit different than the way some of our other systems work. Excuse me. And so what we're actually going to do is we're going to maintain a little bit more data within the individual shader itself. So instead of essentially taking the resource and just copying a lot of that data over to the shader and then throwing away the resource, we're actually going to keep a pointer to that resource as long as the shader is around. So this is a shader resource or a pointer to the shader resource, right? And this is the configuration, or comes from the configuration asset, where we set up all the uniforms and attributes and things of that nature. So this is the resource there. And then that also has a listing for each individual stage. It has a listing of resources needed for that. So just to refresh memory here, let's see. I think this is the one we were looking at. And so when we're talking about the stage data that is present in the resource, we essentially have these what's known as stage configs. We've kind of looked at those a little bit before, where we have obviously the stage type, and then the source asset name and the package that resides in. So the source asset name, of course, points to a essentially a text file where, in this case, our GLSL code resides rather. And so we have one of those for the vertex shader and one of those for the fragment shader or stage. And so essentially what we're doing now is once we have that configuration loaded, we then also retrieve those text resources, which text resources is something we haven't talked about yet. So we'll get to that here in a second, but we do have a new type that is k-resource text. And we keep an array of pointers to those. So when we load those up, we actually are able to keep a pointer to each one of those. And the number of these lines up with the stage configs array, and of course the number of stages that we have. In addition to that, we also have an array of stage source text generations. That's a tongue twister. And so what this is just a flat array of U32s of generations for our stage source text files, right? And so the reason that we have this is because each one of these resources, if we go back into our sort of base resource, we actually have in here, a generation, right? And I'm thinking we probably don't need to have it be a U32. That's probably pretty extreme, but I'm gonna leave it that way for now. But basically, the way that hot reloading is going to work is whenever an asset associated with the resource gets reloaded, or hot reloaded rather, and we reprocess the resource in any way, we increment this generation. And so that generation is then compared against this list of generations, right? So these two arrays line up with one another. So we can use the same index across the board. And the reason we do that is because now that we're maintaining a pointer to the text resource, anytime we hot reload that, we can increment the generation on the resource itself, and then also trigger something to say, hey, we have hot reloaded a resource having to do with this shader. Take a look through and see if we have any of these generations that are out of date. And if we do have any of those that are out of date, go ahead and reload the shader. So that is essentially what we have here now that we're looking at. And so that thing that's going to trigger that is an event that is triggered by the resource handler. We'll kind of take a look at that code here in a second. But essentially, if we get a resource hot reloaded event code coming by, we will go ahead and take a look at the watch ID, although I don't think we actually need, let's see, do we actually, I might have been able to throw that out. I don't know that we actually need to examine that. But basically what we do is we go through all of the shaders, and then any of the shaders that have out-of-date generations or a mismatch at this point, we go ahead and we call shader system reload on that. And shader system reload is pretty simple. In fact, we're actually kind of doing this check twice, right? We probably don't need to do this. I guess we probably don't need to have this check in here, right? If we say reload, we should probably just do it across the board. But I suppose you could consider this an optimization, right? So we check the generation again, and if it's still out of sync, then we go ahead and we wipe out the existing source in the stage configuration for that particular index. So we free that string, and then we take a copy of the string from the resource at that index. And then I actually forgot to sync the generation. So we need to do shader stage source text generations sub I equals, and we'll sync it at this point. We'll just say shader stage source text resources sub I base generation, right? So we will sync the generations, right? And then we call renderer shader reload, passing through those stage configurations, right? So that's the way that the hot reload works there, and as far as the shader system's concerned. There is one thing that we have to fix down here that we're going to address tonight, having to do with the renderer, because we did we did nuke one of our old deprecated structures. So we're going to circle back to this, right? When we're initially creating the render shader, we're going to do a little bit of digging to figure out exactly what data we need. Because before we were passing over this massive shader config object, and I don't think that we necessarily needed to be passing that whole structure across, right? So we're going to investigate that. And then before we jump into that, I did want to just take a quick second to go over the new resource handler for text. Somehow, in our list of resource types reworks, I completely forgot to include text and binary resource types, right? I actually did the asset type reworks for them, I think. Right, we had the handlers for that. I don't actually see it in this list though, but they do exist. But we hadn't actually done the resource loaders, so or the resource handlers rather. And so we've already done the text one. I did that offline. We're going to go over that now. And the binary one is going to be pretty simple as well. So basically the text one essentially reads an entire text file and just grabs the text, and that's it, right? It just stores a string, that's it. Pretty standard and straightforward stuff. The binary asset type, or resource type rather, is going to essentially look at the asset, grab all the bytes, take the size of it as well, and just store the bytes, the byte array and the size. And again, that's it. So this will be useful for like loading, TTF files or something like that. Whenever we need, just a binary blob of something, that's what we're going to use for that. All right. So the resource handler for text is actually pretty straightforward. It's barely 100 lines of code, right? And that's partially because we have like comments and stuff in here. So essentially what this does is this just wraps a request for an asset of type text, essentially. Now, we do take the type directly from, and a bunch of other stuff directly in from the asset information itself. But essentially we take the type, the asset name, the package name. We do have this set to auto release. So whenever we release this, this asset, resource, and the reference counter reaches 0, it does auto release. There's no reason not to do that for a text file. So we have the listener instance. In this case is just a pointer to the resource, which works for our simpler types, right? We have a callback whenever the assets are all loaded. We do mark this as a synchronous asset request. So text reading is actually pretty fast, right? We're reading the whole thing all in one shot. And so that's a pretty fast operation. I don't see a need to sort of multi-thread that. We can just do it synchronously and get it done and over with quickly. And that's going to allow us to very quickly be able to extract out that resource data, right? Maybe in the future we'll make this configurable, but for right now I really don't see the need. So we also have a hot reload callback. We'll go into that in a second. The context, again, for that is a pointer to the resource, right? And then we don't have any import parameters for a text asset. So we make that request, and then that comes through to onResult. OnResult is here. So this basically just takes... we do a cold cast to grab the resource pointer. We make sure that it was a success. If not, we bleat about it and say what the error was. And then we go ahead and we actually take a copy of the text from the asset, right, to the typed resource, right? So we store a copy of that string. And then we have a if asset file watch ID is invalid ID. Or is not invalid ID rather, meaning it actually has a file watch. Then what we do is we go ahead and on the typed resource itself in the base, we add to the asset file watch IDs. And I don't think we did this last night. This was something I added off camera. So this is another new thing that we added to the base resource type, right? And so essentially what this is just an array of watch IDs. So if we have multiple assets associated with it, it's just a way for us to track those watch IDs so that when we shut down the resource, we can actually destroy those watches. So first and foremost, when we load it, we make sure that there's no watch IDs D-array. And if there isn't, we go ahead and create one. If there already is, then we don't need to do anything, although I don't see why that would be. And then we go ahead and we push the assets file watch ID into that array. And then we go ahead and we increment the generation, right? So that's where we start as far as that goes. Did I actually, though? I do need to check and make sure that the generation is actually set to invalid ID when we start. So I need to check the resource system for that. I'm pretty sure we did it, but I need to check that. Okay, so that's on result, right? That's when we first initially load the asset. Hot reloading is a little bit different, right? The signature looks the same, but the way we treat what happens inside is a little bit different. So essentially, again, we do a cold cast. We check to make sure that the asset loaded successfully. We free the old string data, and we take a copy of the new string data. I have a to-do in here to handle like includes at this point. In our files, right? We don't have that, but this is where that's going to live. And this is the only place it needs to live, right? Because we've simplified things. So we go ahead and at that point, after we've loaded the text from the asset, if we needed additional assets because of an include, if we needed additional assets because of an include, this is where we would go ahead and do that. So I've just put it as a to-do for now. And when we come back to do that, we'll know right where to go with that. So after we've done that, we go ahead and tick the generation up one more time. And then we fire off a resource hot reloaded event. The context is the file watch ID if we need that for some reason. But the more important bit is anytime we use this code, which is a new code, we also need to make sure to pass the sender as a pointer to the resource itself that has been hot reloaded, right? So the sender in this case is just going to be typed resource, and we can cast that on the other side, as we saw in the shader system logic. So this is how we're essentially going to handle hot reloading of stuff, right? So we just essentially need to handle this as it happens, but it's disconnected so that we don't have to sort of bubble it up through even more systems than we already do, right? Okay, so that's that. I did say that I wanted to check the asset system, or the resource system really quickly to check to make sure the generation, starts off as invalid ID, and it does in fact do that, right? So when we request a resource, it defaults to invalid ID for the generation. I think for now it's going to be up to the handler. It's going to be up to the handler to actually go ahead and increment that generation. Now I'm rethinking that decision though, because we're going to have to do that in every handler. So we might actually wind up switching that and doing it here, right? So it just always happens and it's consistent. Now that I think about it, that's probably the way to go. So there's that. And I believe we're actually caught up. So I hope all that made sense. Raz, how's it going over there? Good. It has been a minute since I've seen you. I am good. Thank you for asking. How are you? Dingus Dev, thank you for the lurk. Appreciate that. Small question. Not sure if anybody's asked this before. Is there a folder structure that you follow for your project? Can you suggest something on this regard? Yeah. So, there is. So, what we have, and this tree is basically the project directory, right? It's the repository directory. So there's a few things in here having to do with like project level stuff, right? But the important bit is Any folder starting with Kohi dot is a Kohi library of some sort, right? So the Kohi core is a library. The Kohi core tests technically is like a unit test library and executable in one. We're going to change that eventually, but that's where the unit tests for the core exist, right? So it's kind of next to that. We might wind up actually putting the tests for this in the core at some point. I haven't really decided, but anyway. So we have that, and then we have the Kohi runtime, right? So the core is where all of our containers exist, our debug stuff, identifier type stuff like our handles, our UUIDs, our math library, all of our memory functions, our parsers, our platform layer, serializers, our string library, our threading stuff, time, utils, etc., right? That's where all that stuff exists. And the reason that's separated from runtime is because our tools, our external tools and command line tools that we're going to be adding, can reference the core without having to bring in all the runtime specific stuff. So what is runtime specific stuff, right? So it's another Kohi dot folder, right? So it's a Kohi library. And if we open that up, we have two folders in this one. We have assets, and then we have source. I'll come back to the assets in a second. So our source is where all of our code exists, right? So our runtime code is essentially what the application itself that consumes the engine actually uses the most of, right? So this is where our core game loop exists, for example. It's where our individual systems exist, right? Like our asset system, our audio system, all those things, right? It's where all of our resource stuff exists. It's where all of our asset definitions exist, and various other things, right? So resources is sort of the old resources that we're replacing. K resources is the new version of that, right? And eventually we'll probably do some renaming once the old stuff is all completely factored out, just to kind of make that a little bit simpler. But you can think of this as all the new resource stuff. This is all the old resource stuff. We have in here some vendor libraries, which actually are going to wind up moving out of here at some point. So this is like STB image and STB true type. So these are some of the few libraries that we actually do use. These are not going to be included with the runtime. They are going to be included elsewhere, most notably the plugin, utility plugin. In fact, I wonder, I might actually be able to remove those now. Because I thought I did. I thought I already moved those over here. I guess not. Oh, you know what? I moved image, but I wasn't able to move font stuff yet because we still haven't completely finished that. That's why. Okay. So this is in progress, right? This folder is going to be disappearing out of runtime. Anyway, so that's what runtime is. And then we have Kohi.plugin is where all of our plugins exist, right? So if it's Kohi.plugin, it's something that's not in the core engine or in the core runtime. It is something that is ancillary to the rest of stuff. So it's optional, essentially. And so we are designing Kohi so that it's with a plugin architecture in mind, right? So the renderer backend itself is a plugin. The audio backend itself is a plugin. The UI system is a plugin. You don't have to use the UI system. It's a plugin. So it doesn't exist in the UI, right? Or in the runtime. The advantage there is that games often don't need like text boxes and check boxes and standard buttons and scroll containers and things like that, right? Like a lot of games don't need that stuff, but an editor would, right? So why include that in the runtime if we don't necessarily need it? So things in here are like our debug console, our drop-down debug console that comes down from the top of the screen also exists in there. And so we can choose to include certain plugins in a debug build, but not include them in a release build as well. And so the UI standard library is one of those examples where we could potentially do that. Also, the utility library is another example of where we do that. And so, it's just to keep the center or the core of the engine as lean as possible. The reason that our renderer backend is a plugin is because we're going to have different ones. Right now we only have the Vulkan one, but eventually we're going to have a Direct 3D renderer backend and a Metal renderer backend, and so we would obviously only want to use that plugin on platforms that support it, right? So why have all that stuff always included in the core when we're building, right? You could just use a plugin or not use a plugin. The audio system is the same way. The audio, right now we're using OpenAL as our audio backend, but we could just as easily implement a plugin for Fmod or something like that, right? So that's a plugin as well. So that's plugins. Tools are just ancillary tools that exist outside the engine's core, but it's like pipeline tools for like converting assets and things like that. Utils, I guess skipped over utils. Utilities has importers and exporters. So those are examples of things where you might want to have an image import where like you import a PNG image and then export that to our native Kohi texture format, right? And so it doesn't make sense for our importers to be in the runtime, right? It makes no sense to do that. And we also wouldn't need those on release builds either, right? We're only going to be importing assets in our game and debug builds, right? Because once we've imported the asset, we actually write the primary asset out to disk, and then it's imported and we just load that going forward. So we don't need importers and exporters, for example, on release builds. So that's a plugin. Circling back to runtime for a second, I mentioned we have our source here and we have assets next to that. So our packages, our asset packages, can also go along with one of these libraries, right? So we actually have a runtime K package is what we call them. And that everything that is contained within that lives in this assets folder, right? So we have images, which is like all of our textures, right? That's things that wouldn't be included in the runtime by default, right? So we package these textures with the runtime by default, right? So these KBIs, those are our native sort of format, and then the source files we keep with it as well, right? So whenever we run that importer, we would import these PNGs or JPEGs, whatever, and then we write out a KBI file to disk, right? And so we keep both versions here in case somebody wants to change that for some reason, or so you have the source assets, but all of these assets are packaged with the runtime package, right? So all of those assets themselves live under the assets, and then they are referenced in an asset manifest, which is what we have here. So this is what the asset system uses to say, I have an asset that is named this, right? And it exists here on disk. So in debug builds, we would load that directly off disk. In release builds, we actually would have a binary package that all of the assets in this file get rolled up into, complete with a lookup table and all that stuff. So that is why all that exists. And then finally, our testbed in this case is our sort of application. So this testbed asset.assets thing is going to be going away. That's a legacy thing that we have in place now, but that's going to be going away once we're done with this refactor. So we have the testbed.kapp and the testbed.klib. And again, these things are fairly standardized. This is what we're going to use going forward. So the kapp is a very lightweight application. So it only contains one source file, which is basically the entry point of the application that consumes the engine, right? So testbed in this case is our test driver application that is what we use to test new features as we add them to the engine. And so this is very lightweight. It's an executable. And the reason that we keep that separate from the klib, which is the application code, is because the klib is actually hot reloadable. So we can actually rebuild this on the fly as the application's running and have the new code just pick up and run, right? There are considerations to be made, obviously, when doing that, and we've gone over that in the past, so I won't go into depth on that here. But this is where the application code exists, right? So this is where the game code would be for a game. It's where the editor code would be for the editor. Those are both examples of an application. And so that's where, all of that stuff exists. So the klib is referenced by the kapp, and then the kapp is configured to use whatever plugins. It's up to the application what plugins get used and which ones don't, and so forth. And that's basically our standardized structure, right? And then we have one in here called zgame, which is something that we were kind of experimenting with in terms of setting up a new application. I'm probably going to wind up throwing that out and having to redo it because of all the changes that we've made. But when we go to stand up our game, that's where it's going to sit, is in there. So we actually come up with an actual name for it. But yes, there is a standard folder structure, and that's basically it. So I hope that, I know it's very long-winded, but I hope that answers your question. From Lake, it's good to see you over there on the YouTube side. How's it going? Awesome. Yeah, no problem. All right, so okay, so we verified that the generation is doing the thing. So what I actually want to do, I'm going to open the K-resource system over here for a second. I'm going to go back to I think I did that in the text handler. Okay. I'm actually kind of thinking about changing up the way that this works a little bit. So what we have here is when we make our asset request, right? We fill in our callback here, and then we send that off to the asset system. I wonder if that is something that I should make generic for now or not worry about it. Because it would be kind of nice to have it at this level and not have to do it all the time. But so in the K-resource system, whenever we request a resource, if the resource already exists, then we just immediately make the user callback passing that resource, and we're good. If we don't have the resource, then we essentially find we perform an allocation for that resource, right? And then we go ahead and create a new node internally, a new lookup. We default a lot of its base properties, and then we make the actual request going to the appropriate handler. So the handler is defined here. So our state handlers is just an array of K-resource handlers. And we index that by type, right? So if we take a look at K-resource type, we actually have all of these here, right? And so obviously, text would be index 1. Unknown would be index 0, which technically there isn't an unknown, right? But we have that as 0 since it's kind of a default. So for textures, it would probably be 3, right? And so we're able to quickly index that just by the type that's passed in and get a pointer to that handler. And then we just call handler request, right? So I think, you know what, I should probably, H is kind of a crappy name for that. Let's call that handler, right? So we perform the request. That request ultimately becomes a call to something that looks like this within the actual handler itself. And then that's when we make all of these calls, right? So I suppose we could extract the info at this point, right? The callback information at this point, and use that. And you know what? I'm not gonna mess with it for now. I just want to get this working, and then we'll circle back if it's too much of a pain in the butt to write. Yeah, I'm not gonna mess with this for now. Let's start closing the loop on things instead of opening more loops. All right, shader system reload. Let's see. Okay, so I actually think that we're done for now, anyways, with the. I think we're done with the resource itself. I think what we need to do now is actually switch over to the renderer, because we actually have the two issues with this file. And the fix me that I have here is change the renderer to use resource instead of config. So the config, let's take a look at the renderer front end, right? And actually, we've got some type issues here, right? This shader config no longer exists. It was a deprecated structure that we had in place. That was a result from the old way that we handled shader resources. We don't need that anymore, and so we need to actually start removing references to it. I don't want to do this one first because I know that that's in the backend interface. I want to figure out the front end first, and then, well, I guess we might have to work from the back end upwards, now that you think about it. But this right here was taking a pointer to a shader config, which we no longer have. So my first thought was that we can come over here and we could just change this to take the shader resource, right? Just a pointer to the shader resource. And that might be fine. But instead of doing that, I want to actually take a look at what the Vulkan backend actually needs from this, and that'll determine what we actually need to pass, right? Because maybe we don't need to pass that whole resource. Maybe we do, but maybe we don't. So let's go to the back end. And of course, that's also bleating about the shader config stuff, so we'll fix all that. See, we've got shader config stuff here too, so we're gonna have to adjust this in a few different areas. But I think a lot of these errors are gonna go away once we actually figure that out. Okay, so the renderer, the Vulkan renderer shader create. This is what ultimately gets called when we make this call from the shader system, right? So it looks like we need stage count, stage configs. Here, I guess we're just making sure that we actually have support for all the stages that are supplied. Let's see, we need the flags, the stage count, the topology types, uniforms, max groups, max per draw counts. Yeah, I think we are going to need the whole resource. I think we are going to need the resource. So let's go ahead, I guess, and do that. We're gonna change this. This is going to be k resource shader, right? I'm going to leave it named config for right now, and then we're going to do a rename once we fix all the code issues. So let me go to the header file, and we're going to do k resource shader there as well. Okay, so that eliminated a bunch of errors, like 2/3 of them. So all we need to do now is essentially go through here and figure out the rest. So internal shader name, config name was a string before, so I think now we can actually just use, I think it's going to be base name. And we don't need a k name create here because we already have a k name. this is already a K-name, so we don't need that. Okay. Set up frequency descriptors, and that is taking a config. So we're going to have to change that function. So what we're going to do is, I'm actually just going to browse to it real quick, go back, and we're going to say k resource shader, and then down here we're going to do the same thing. Okay, and that eliminated a bunch of other errors. We know about the errors in our H files. We're going to come back to those. Okay, so here we're just outputting an error message. I'll bet this is a name issue. Yep, it is. So this is going to be base.name. And then we need to actually do a kname string get on that. Oops. Okay, next error. This is going to be the same thing. So base name and kname string get. And the next one, same thing again. And this needs to be base name. And okay, create shader module. Okay, so this this particular thing, what this does is it takes the shader stage config and calls create shader module, which I believe just takes the source string, but also the file name. But if I recall correctly, I think the file name is only for error reporting here. So if we take a look at file name, yes, it's required by shader C, and I don't think we can pass null. I think there was issues with that. So this is basically what takes the GLSL and converts it into SPIR-V. So we do need the file name here, or we need to at least pass something. It doesn't actually open the file, but I guess it needs it for reporting or something. It's kind of a strange API decision that they made there. But I have tried passing null, and it's not happy with that. So what we can do here is, let's see, shader config. We have sc file name. Let's see what the actual error is. No file name in config. Okay. So we have package name and resource name. So I think we might just go with resource name. And then this is no longer a k-string ID, it's a k-name ID, string get rather. All right, so there's that. Unable to create shader module for whatever shader. Okay, so this is going to be, instead of file name, because I think that's what it's complaining about. Yep. We're going to do resource name again, but we're going to have to do kname string get around that. And I think that'll be sufficient. Okay, so there's that. Now the other two issues are in header files. So what I'm going to do is, this is actually fall through from renderer types. So I'm going to fix renderer types first, and then I'm going to fix the back end. So this just needs to be k-resource shader. And we're actually going to have to change the comments on this because those are going to be wrong too. But again, I want to fix the code first. So that resolves that. And then the renderer front end. needs the same update, right? So we have that. And same update. Whoops, that messed up. All right. Okay, save those, and now we are good to go. So I can rename these now. This is going to be shader resource, is what we're going to call that. We're going to do shader, shader resource here. And this is going to be, instead of config, a constant pointer to the shader resource. All right. So that's that. Let's see. We need to go to this guy. And here we can just call it shader resource. And change the name of it. And then the Vulkan backend. Let's see, where was that? Here. Shader resource. And same thing here. Actually, wait a minute. I want to do a rename on this one, so that we don't have it called config anymore, right? Okay, so that resolves all those issues. Tech 256, raiding with a party of 32. Thank you very much for the raid. How are you doing tonight? What'd you get up to on stream? Welcome, raiders. Going to give a quick shout out to Tech 256. So allow me to just do a quick introduction here, so that you guys know what the heck we're doing. Just some GLTF implementation stuff, not very much accomplished. I get that feeling. I felt that was the way my stream kind of went last night, but we did accomplish things, but sometimes it doesn't feel like it. I totally get that. GLTF is on my to-do list for sure. All right, so what we are doing is we are making something called the Kohi game engine. It's an engine written in C from scratch using Vulkan as our initial rendering backend. I say initial rendering backend because we plan on also supporting Direct3D and Metal at a minimum. And so the idea is that this is an educational series on documenting the process of building a game engine and ultimately games with that game engine. And so it's kind of the resource that I wish that I had when I was learning how to do this stuff. So it started off as a YouTube tutorial series, but it quickly outgrew that format. We tried a few different things, ultimately landed on the live stream format that you see here. We do simulcast to YouTube and Twitch. So the engine itself is open source. It's on GitHub. It is free and open source. It is Apache 2.0 licensed, which means that you can use it for whatever you want, whether it's personal or commercial, does not matter. All that I ask is that you say that you used it, and that's it. There will never be any sort of licensing fees or royalties of any kind ever. It will always be free and open source. Because it's educational, I believe that a lot of education should be free. And so I don't have any like sponsors or anything like that. I don't paywall anything. I'm pretty against that, right? So, my only sponsors are you guys, the viewers. So, yeah, that is essentially that. It is cross-platform. It runs right now on Windows, Linux, and Mac OS. We do have other platforms planned for the future. Most notably, probably Android and iOS. And then we have a couple of other links down here towards the bottom. Again, our YouTube and Twitch links. We have a Discord server with just over 1,000 people on it. A link to our GitHub here, and of course a Patreon link if you're interested in supporting my work. And that is basically it, right? So what we are doing right now is we are in the middle of a quite large refactor, preparing for our first game, right? So since this started off as a tutorial series, we had some technical debt that comes from that kind of format. And so we're resolving that technical debt now. And one of those things is to standardize the way that we handle assets and resources within the engine. So we're going through and replacing all of our old systems, which kind of had a very ad hoc, sort of on the fly way of doing things, and it wasn't very consistent. Again, due to that sort of tutorial format that we were following, and we're making everything consistent and reusable where possible, so that all assets and resources kind of follow somewhat of a basic framework. And so that's what we're working on now, in addition to like asset packaging, things of that nature. And we have been working on asset and resource hot reloading tonight. So we've got that just about stitched together. We had some minor things that we had to fix in our renderer, but I think that that's fixed as well. So I'm thinking we're probably at a point now where we might actually be able to jump back to our material system, which was the last thing that we were refactoring. So we've refactored our texture system already. We've refactored our shader system. I think that's actually pretty much done at this point. And we're in the middle of refactoring our material system. And then once those things are done, we should actually be at a point where we can run the engine again and test all of that out. And we'll work out any bugs that have come up along the way before we finish off the final systems. So I hope that introduction makes sense. I hope that makes sense to all of the raiders here. Welcome, guys. If you're interested, feel free to follow, right? I'm trying to grow the channel, trying to motivate people to make game engines, because I believe that having competition in this space is a good thing, and we need more people out there doing it. Competition is very healthy for the industry and tends to lead to innovation. So anyway, that's my spiel. Thank you very much for the follow. I appreciate that. All right, so what's the warning that we have here? Oh, we just don't need that anymore. Okay, perfect. All right, so no warnings, no errors, so we should be good there. I suspect, let me actually remove this fix me because we've done that. I suspect that we might be getting close to going back to our... Oh, looks like we have something in the asset system. Okay, so let's take a look at that. Let me come over here. What did I miss? Wait, did we not included the header for this, but then didn't use it? Oh. I must have pasted something there by accident. Okay. Unused variable file watch ID 108. Wait, was that... What file was that? Shader system. Okay. That is over here. Oh, yeah, I was saying I wasn't sure if we needed this. We don't. However, though, I'm going to leave it there because we do pass it. Right, so we'll just leave a note there that that's available if needed. Okay, all right. Oh, terrain loader. Okay. So let me actually move this over here so that you guys can see it, because I think that was behind my head. So I mentioned that we're replacing our resources, our sort of old way of doing resources with a new way of doing resources. And so anything that has loader on it is basically an old version of resources. So we haven't gotten around to terrains yet. And this is bleating about a shader config in there. So let's just take a quick look at that. I really don't want to open this can of worms tonight, but if I can just get it to compile, we're not going to use terrains just yet. So this is the lone error. and it's a size of shader config, which is interesting to me because I don't think that's right. I think that's an interesting copy pasta. Resource data. So this should be terrain resource. So that's an interesting bug. Okay, I wonder how long that one's been in there. Okay, so shader loader. Okay, so this shader loader is something that we're replacing. However, I don't need to finish that one because we now have the new shader resource loading in place. We can actually nuke the shader loader. So we don't need that anymore. So we can go in here to runtime. Let's close this. And we'll go into your resources here, loaders, and shader loader, right? So we can actually delete this and delete the header file for it. And then I'm thinking, I think there's going to be something that that makes use of that. That's going to bleat about it now, but we'll find it. Oh, we're going to have to clean because that no longer exists. Resource system. So resource system, this is the old resource system. And I can't remove it yet because it still is in use as we're kind of swapping things out. So what I'm doing is as I'm replacing these things, I'm just crossing these things out. Mesh resource loader create. I don't know why I bothered commenting that one, but I guess I'll leave it there. Eventually this file is going to get nuked anyway, so I'm not really too worried about it. Oh, we got something in the VFS. Let's see. Oh, it's the asset handler for materials. Right, we probably didn't convert that one. So, an asset handler is basically what handles loading the asset off disk. So, the asset system that we have has one of these handlers for each type of asset. An asset is basically the in-memory representation of an asset from disk. And so this is a material type asset that reaches out to our virtual file system, which in turn manages our packages. And that in turn either points to something on disk or in a package. And so we've actually been going through here and we made some changes to our VFS, our virtual file system, to now take a struct instead of 1.5 million parameters. And so that's what it is basically bleating about. So we need I think it was just request info. Yeah, VFS request info. And we basically just fill one of these out and then pass it instead. So request info is going to be, let's see, package name is going to be asset package name. Asset name is going to be asset name. Let's see. Looks like we got some questions over here. All right. Yeah, let me catch up on some of these. Using C++ for mine so far. Please don't judge me. Nah, I don't judge. I just prefer C over C++. No worries. My JSTS brain is is running at full speed, trying to keep up with what's happening, but it's cool to watch. Yeah, no worries. Yeah, so I actually do a lot of that stuff for work anyway, so I know where you're coming from. But yeah, this is all written in C, so it's the syntax shouldn't be too much different, other than things like the arrow syntax and whatnot, right? But we are trying to work in a sort of non-OOP way here, as opposed to the way that TypeScript kind of forces you to try and do everything OOP, right? we are trying to avoid that wherever possible in this project because it just doesn't make sense most of the time. So we do have structs that we pass around, and we do have some things that have like a base type to them, and we use some casting and things like that. But some function pointers and things like that. But we don't really we don't do full OOP around here. That's for sure. Ninja Sky, how's it going? Good to see you. Is this for Unreal Engine 5? No. This is our own engine written from scratch. Let's see. I'm building a graphics programming roadmap list that I'm going to post around. Since you have a lot of experience, do you... scrolled. Do you have any suggestions for first projects to push people towards, specifically someone's first project after learning an API? So assuming they've learned like Vulkan or probably OpenGL as opposed to Vulkan, right? For their first one. I always say to make simple kind of 2D games first. Simple renderer, nothing super flashy, right? Maybe like a top-down tile-based game, or like a platformer, simple platformer, something like that. Something relatively simple, because just doing that alone is going to expose you to all kinds of things that are outside of just a graphics API, right? Having to figure out how to write various systems for games and stuff like that. Another thing that I usually suggest outside of just APIs, and those of you who are whoops, that's the wrong button. Those of you who follow this stream regularly know I recommend this book all the time. There's a book called Game Engine Architecture by Jason Gregory. And this gives an insight or an overview to all the various systems within game engines. And it's a fantastic resource for that. And it's a thick book, right? It's really thick. It's at least 2 C's thick, if not 3. But essentially, it gives a really good overview, starting from the bottom up, right? And really exposes you to all the other things outside of just a renderer when you're actually making a game. That is in the context of a game engine. However, even if you're not writing a game engine, if you're still, just writing the game, and the engine's sort of part of that, I still think that's a very valuable resource. So yeah, that is where I would start, assuming they've already learned the API. Is with a project like that. Keep it simple. And then, gradually add and increase your knowledge and do more complex things. It's mostly C-like, at least. Yes, true. What do you think of writing mostly C and CPP files to access the small CPP features like method and operator overloading? So that's actually how I worked for years. Before I made the switch to C. The only things that I used in C++ were generally operator overloading, and constant expressions, right? Constant expressions. I tried to avoid function overloading just because I'm not a huge fan of that in general, but there were some uses for it, right? So that's another thing. But yeah, I don't see a problem with that. I always called that C++ light. And so yeah, I used to do that all the time. That was the way I coded. IQF, how's it going? Or I guess it's IQ forget. Sometimes I fail at reading names. But hello, welcome to the chat. So is this a new dev tool? What do you mean by dev tool? Do you mean my editor, or do you mean the engine in and of itself? It's a brand new engine that we're writing from scratch, if that's what you mean. You're in cybersecurity, nice. That's an interesting field. I don't know too much about it. I'm not a security expert, but yeah, it is interesting stuff. Actually going to another language, currently divided between Nim and Elixir. I've used neither of those, so I can't talk on them. Feels limiting just knowing one thing. I absolutely agree with you there, for sure. I always think it's good to branch out and try different stuff. Absolutely. Let's see. How's it going with your programming? What are you working on right now? So we are working on refactoring our asset and resource handling across the entire engine. Um, so that's essentially what we're working on now. I'm actually working on stitching things back together after a massive refactor. Um, and so we're kind of just working our way through the list of errors that have come up on all the stuff I've changed across the code base. Let's see. Pokemon clone, platformer, 2D dungeon crawler, etc. Yeah, those are all relatively simple projects. What book is that? Just got back from ads. Oh, I didn't even see the ad break. Okay, sorry about that. So it's Game Engine Architecture by Jason Gregory. And it's a very thick book, right? But it's worth it. Worth every penny. I've read it cover to cover a couple of times, several times. It's a really good book. Good batch render is within the capabilities of most beginners, I feel, so long as they're comfortable with the language and actually take the time to read. That is true. Let's see. First game was Notepad and Command with Node.js. Yep, I get that. I've done stuff that way too. I was also going to suggest a Doom Wolfenstein styled game if someone was more into making something 3D, basic terrain, or dungeon generation, something along those lines. So I usually say if you've learned an API, a graphics API, and you're kind of setting out to make your first thing, I usually suggest 2D first. Because adding that third axis can complicate a lot of things. Whereas starting off on just simple 2D simplifies a lot of your calculations, right? Definitely jump to 3D after you've got a little bit of experience, but I usually say start with 2D first. I know everybody wants to start with 3D, but I generally recommend against it. What are your thoughts about AI and I assume you mean response in games will be added soon to games? I'm not a fan of it. I've never had AI generate anything that I would actually use in production ever. It's always subpar. And to be honest, a lot of the stuff is like sourced on things that aren't necessarily or weren't necessarily licensed to be sourced anyways. So I don't use that stuff at all. Did you write your own allocator for Vulkan? Yes, we did. It's simple, but yes, we did write one. We are going to be at some point probably refactoring that into something a little bit more advanced to handle all the different types of allocations correctly. But yeah, we do have our own. That book, Real-Time Rendering, which, yeah, I do have Real-Time Rendering back there as well. And a book on 3D math are the holy grails of graphics programming books. Yes, I agree with that. If you're super serious about learning 3D programming, highly encourage the purchase of real-time rendering and game engine architecture. Yeah, so this is the real-time rendering book that you're mentioning right there. So yeah, it's got a stormtrooper in the front of it. But yeah, this is a really good book too. It's another thick one. It's just as thick as the game engine architecture book. Let's see. Maybe you can fix Windows 11 so it's not running way too many things. Yeah, no, I'm not. I'm running on Linux now because I try not to run Windows on purpose. Battlefront 2 is a masterclass in graphics programming IMO. I see how you get there. Yeah, I get that. Let's see. Let me catch up on the YouTube comments. You're writing this in C, you sir are my hero. I appreciate that. Yes, the whole thing is in C. No C++ here. Is the game engine for low type of development or high end like production type? It's both, I'm going to say. Here's the thing about it. Like it goes into kind of high level detail on how a lot of the systems work, and sometimes it dives into a little bit of detail on like what an implementation might look like, but it's not so low level that I feel like it's out of the grasp of most people to be able to get. You might have to read it a couple times to get everything, right? But I think that's okay too. It is a wealth of knowledge. But I think it also, even for somebody that's not looking to write their own engine, it'll give them an understanding of how all those systems work, generally speaking. So I think it's good in general, even if you're not planning on doing low-level dev. Zani, how's it going? Welcome. I was going to use C, but I know that I'll end up writing my own vector, string, etc. And also I know they would perform a magnitude of percent worse than what C++ offers. I despise OOP though. Yeah, so I mean, we wrote all of our vector classes and our string classes here, and I haven't had any performance issues with those at all. So it's not really, just keep it simple, keep it light, and you'll be fine. It's not really that big of a deal, to be honest. Is it true that when a game is loading a new level or scene, the gameplay actually stops entirely while the loading happens and then resumes afterwards? Or modern games using techniques like preloading, trailers, or seamless transitions to hide the loading process and maintain immersion? Highly depends on the game and the tech. Right? If you have something open world, it's going to be constantly streaming in assets. You still have games where you have a loading screen pop up, right? And then that's, generally the simulation stops at that point and you just load stuff. And then whenever everything is finished loading and it's ready to be presented, then all those systems kick back on and it renders. And then you also have games that have kind of like a mix between the two, where you'll have like level A over here, like you'll have one zone over here and you'll have one zone over here, and there'll be a super skinny path that you have to sort of go through, and the camera angle gets really tight as you're going through that, and what it's actually doing is it's shutting down zone A and bringing up zone B while you're transitioning through that. So that's like another thing that happens. But yeah, it's a mixture of those. It highly depends on the game. Rockstar needs to quit playing with my emotions and open source their engine. That's never going to happen. Never going to happen. Honestly, I want to know if I'm wasting my time or not, or should I just code my own engine? So the way I always answer that question is, what is your goal? If your goal is to learn about the underlying tech, then absolutely I would build an engine. If your goal is to just make a game, and an out-of-the-box engine fits those needs, then use that, right? If you're wanting to just make and release games, and you don't really care about the underlying tech, which I think is a bit of a mistake, personally. But if that's your goal, just use that, right? I always recommend any game programmer at least try to write their own engine, even if it's a small, simple one, at least once, to get an understanding of how that stuff works under the hood. Because then when they run into issues with a pre-boxed game engine, they'll actually kind of have an understanding of what it's doing under the hood, and your debug capability will be a lot better. You'll be able to troubleshoot it a lot more effectively because you actually have an understanding of how those things work. But yeah, that's kind of my 1/50th of a dollar bill on that one. Next best thing is to get a job at Rockstar. Guess that's my route. Yeah, I mean, you could do that, right? But then you can't use any of that stuff outside of it, right? Because that's all proprietary and highly, NDAs and all that stuff. So let's see. Hope you all the best. Good night. I followed you. I appreciate the follow. And good you use Linux. Yes, I do. I do use Linux by default. Have a good one. Let's see. Unreal Engine is kind of limited, yes, and it's kind of huge and heavy too. So that's something to consider. You have to ask yourself, even if you're even able to write something that can perform a specific task better than how UE does it. Yeah, and there's all kinds of things, right? Are you able to do it? Do you want to take the time to learn that and the time to write it? Because we've been at this engine now for 3 years. Now, granted, that's 3 years part-time, right? I'm not working on this full-time. This is my hobby. This engine is my hobby, right? And I put less than full-time hours into it every week because I have a full-time job outside of this. So, I've been working on this over 3 years, but it takes a while to write your own game engine, right? Before you can actually do anything else. So that's another thing to consider. Um, yeah, I mean, so if I were to summarize this, if I were to take this and combine it into like full time hours, it's probably sitting at about 9 or 10 months of work, I would say at this point. If I were working at this full time, this is about 9 to 10 months of full time hours work to get this engine. Let's see. What do I do for day job? So that's changed actually since I started this project. um, it's changed a couple of times actually. So I did write game engines full time for about 5 years. Um, and I was working for a studio writing a proprietary game engine there. Um, and I got tired of working 70 hours a week, so I left that. And I switched to a uh, a company writing medical software, specifically software that is used by hospitals. Um, and I stayed there for a little bit, and then had something else come up where where they were developing a like a 3D room planning application. So it's a little bit like you can drag and drop stuff and make kitchen cabinets and that kind of thing, and design those all out and spec them all out and draft blueprints and that kind of thing. I worked on that for 2 years, but then I wound up getting laid off from that job in February of this year, and then I switched back to the medical company, and that's what I'm doing now. Um, so yeah, um, I could tell you the studio, but it wouldn't matter because all their products ship overseas, so you're probably not even aware of who it is. Did you work for WoW? Nope. Nothing in AAA. Um, it wasn't AAA. It was actually the casino industry. Does every AAA studio crunch? I would say probably yes. There's probably way less that don't. I'd imagine that the WoW engine is held together by strings. I would say duct tape and rubber bands by this point. It's old. So yeah, you're probably not wrong. Am I using STL? No. We implemented all the platform layers on our own. So we have in the core, we have this platform layer. And within that, we have, I'll just expand this just a little bit more. So there's one for Linux, one for Mac OS, one for Win32. We have all the OS specific logic in there. This platform Nix is kind of some overlap between Mac OS and Linux, and actually a lot more code's probably going to be moving to that. But yeah, we wrote all the windowing code, all the threading stuff, all all that kind of stuff, input, all those kind of things are all implemented for the individual platforms in here. We did not use a library for that. What is your favorite GUI design paradigm? Depends on the application, right? So immediate mode is really nice, but it's not cut out for everything. And retain mode can also have its advantages. So I tend to stick to retain mode for games, for the actual like game UI. And then I tend to use immediate mode for like an editor type UIs, that kind of thing. But again, it depends on what the actual application that you're building needs. So it can vary. You have a lot of videos to catch up on. Yeah, there's a lot of content for sure. This is what, episode 252, I think. So yeah. Okay. Fellow healthcare dev checking in. Awesome. Good and bad at the same time. Yeah, I get that. Is that NeoVim? Yes, it is. This man making me want to use Linux now. Arch, by the way. All the way. I have to say by the way because it's just, it's Arch. You can't say Arch without the by the way. All right. I should probably actually code. So, I needed to finish filling out this request info. So, what did we have here? We had, let me close some of these other things, get this out of the way. Oh, I have to remember what the order of the old arguments was, because I totally forgot to notate that down. Let me see. Do I have it written down somewhere? I do. Okay, so it was, let's see, so package name, well, asset name, I guess, and then package name. And then we have is binary and then get source. So in this case, is binary is false. Request info get source is also equal to false. Request info. So this is going to be the context size is equal to this here. And then request info context is just the address of context that we put, that we built up here. Request info dots, what's the next thing? It must have been import params, I think. So import params, we didn't have any for this. Request info, import params, size. We didn't have import params for that type. And then the VFS callback is this guy. And I think that might be everything. Watch for hot reload. So I'm going to turn hot reloading for materials off for right now until we actually write or finish up our material system, and then I'll build in hot reloading for that. So to do material resource hot reloading. I'm just not going to implement it for this right now. Okay, so what we need here is just request info. That's fixed. All right. System fonts. You're doing a synchronous request there. Interesting. Okay. So I'm actually going to copy this. And let's open up the system font asset handler. So basically any of these VFS requests, we have to just essentially rework into one of these structures here. So this pretty much looks the same. We do have a different callback. Okay, so this one was actually kind of easy. So let's do let's see, request info. And then we're going to do font resource hot reloading. Actually, I don't think fonts ever need to be hot reloaded. I don't see why we'd ever do that. This seems kind of silly. So we're not going to support it for that type. What else? Another request. So this request is for the TTF file. Do we want to do it this way? I think, yeah, okay. So actually, I'm going to take this. We're just using this instead of passing a billion parameters, essentially, is what we're doing. So I just have to convert all these functions to kind of do it the new way. So this is going to be typed asset, and we want TTF asset name. And then, whoops, that actually needs to be there. Context asset package name needs to be there. Binary is true in this case because it's a font file. And then we don't have any context. No import params. And let's see, we have the font file data, which was passed before as a reference. I think now it just returns. So we can just say font file data equals that. And then we can change this to just request info. And that fixes that one. And then this is going to wind up being almost the same thing. So let's see, do I want to do, I'm going to have to rename it, which I guess is fine. So I guess we are, okay, this is basically trying to load the same thing, but with a, from any package, instead of trying to load it from the same package. So the only thing it needs to change here is the name of the package. We should probably rename this. Any package request info, and then we will do that. Okay, so that should be solved. I'm gonna do that just to make it a little bit clearer. Let's see. Oh, how do you test your Windows and Mac stuff? VMs, dual boots, Windows and Linux plus has a MacBook. Yep, exactly. So you're exactly right on that. So I did get a MacBook 2 years ago ish. That's actually what I stream from, right? So I have this this machine. This is my dev machine, what you guys are seeing, but the actual stream is run on my Mac. Because graphics programming on the same machine that you're streaming from, it's like playing Russian roulette. It's a bad idea. I've lost streams that way, you know, because there was some driver bug that actually crashed OBS, and then it's just, yeah, it's not great. So yeah, I made that separation quite some time ago, and it's been pretty good. But yes, I test all the Mac stuff on that, and then this machine that you guys are looking at dual boots between Windows and Linux. And then I also have another machine that I actually built on stream under the desk, and that one also dual boots Linux and Windows, but it's instead of having an NVIDIA card like this one does, it has AMD, and instead of having a AMD processor like this one does, it has an Intel processor. So I can test it on both of those things. And then the Mac M1, of course, is ARM-based, so I kind of have all the bases covered that way. Or at least most of them. Okay, now we are back to where we were before. So, the forward render graph node was essentially where we landed before we started all of this hot reloading stuff. So hot reloading, we can cross that off the list now. That's done. In fact, Let's pull up the to-do and see if we can cross some things off. So we still need to write that. Materials, we still need to, we're working on the material system. So shaders are done. And text is done. I already marked that as done before. Let's see what else. I think that's system font. We do need a resource handler for that, but that can wait. Fix hot reloading, change watches to be called from package VFS. Okay, this is actually done. Let's see, is there anything else in here? Oh, asset hot reloading, that's done. I still might want to change how it's done, but it's done, at least for now. It's supported. All right, and I think most of this stuff is just one-off stuff that I have to fix along the way. Bugs and so forth. So we actually have a decent amount of the way stuff done. And some of these things are quick, and some of these are not quick. Thankfully, the number of not quick things is actually dwindling. A lot of these are going to be fairly quick. And some of these are going to get punted off to the next version so that we can actually start in the game. Okay. So we have that. Clear. Let me see. Oh, it might help if I was in the right folder. Git status. Okay, I think I'm actually going to commit what I have, because we've done a lot of stuff between this stream and the last one. And I think that is worth... I think that is worth committing, right? Okay, so... shader resource and hot reloading. Various refactorings of resource types, related resource types. Cool. So that is pushed. And of course, that's pushed to a feature branch, right? And this feature branch still doesn't build, but that's fine. It's not in development, right? So let's see. Need to build an Intel box. My current box is all AMD, and my laptop is N1 Mac. Yeah. K handle. Yep, candle. It could be pronounced candle or she. You're not wrong. Yeah, so that was the reason I built the machine that sits down there, which I don't actually have booted up at the moment, but it's because I ran into specific issues with AMD GPUs on Intel machines, which I've since fixed, but yeah. It's like one of those things I have to have like the different platforms and hardware of the different platforms to actually test stuff. All right, so what we need to look at now is the forward render graph node. We were in the process of taking all of this stuff having to do with material shaders and stripping it out of here and moving it over to the material system, which is here. And part of the reason that we wound up doing the shader refactor is because one thing that I wanted to support is if we take a look at our standard material, or is it material standard maybe? Yeah. if we take a look at this definition file, right, for the standard material, right, this gives us all of our stages, our attributes, our uniforms, etc. One of the things that we're having to do is we're having to like hard code, sort of like the max number of groups, which in this case means the max number of materials we can have, and the max number of per draws, which is actually not in here. And we'd have to like manually sync this up with numbers that are in the material system, and I don't want to do that anymore. So what we're actually going to do is we are going to, instead of loading this file from disk, we are actually going to generate this in code and essentially send this text over to the resource system and say, hey, give me a shader resource, but use this string of text as the actual source of the file instead of loading it from a file, which was one of the reasons that we did that. And if we come down here, did we actually have that in here? Or I think we had started laying it out, or maybe not, I forget. Material crate, no, I guess not. I guess we didn't. Okay. Oh, this is probably it here, actually. Yeah, here we go. So we create a fake, oh, this is for materials. So we're kind of doing the same thing with materials already, but we haven't done that with shaders yet. So the material system has specific shaders that it needs to know about, that are built in, that always come with the engine, that have to be there in order for the material system to work. And so to me, it's a little bit silly to actually have this on disk, right? We could just generate this based off of data we already have in the material system. We could generate this configuration and still load these things off disk so that we have hot reloading, right? But even maybe in a release build, we could even maybe move away from that eventually. And so we have these three handles right here to the individual material shaders, right? So one for the standard shader, one for the water type of shader, and then one for the blended shader, blended materials. And so what I'm thinking is, instead of retrieving this from the shader system as we would normally do, we're actually going to, we're essentially going to send it this string that's constructed here in code to load that up instead. So if we take a look at, let's see, material standard shader. So right here, where we're doing the shader system get, and we kind of just pass it a name. That name, right, is right there, shader.materialStandard. And then that in turn loads, eventually loads this file, which loads these files, and then turns on the hot reloading and all that stuff. We are going to actually, we need to modify our shader system to take in a string of source, right, so that we can then pass that on to the resource system. That's just adding another function to the shader system and just passing it through. That's not a huge deal. So we're going to do that. So I guess we should probably knock that out. So what I'm going to do is I'm going to take a copy of this actually. And we're going to say get from source, right? And this is going to be shader config source. And we're going to have param shader config source, a string containing the shader's configuration source as if it were loaded from an asset. The given name based on the provided config source. Okay. Instead of search for, this is going to be the kname2, or the kname of the new shader. And actually, this should just be name of the new shader. A new shader if found loaded. So we're just going to say loaded because we're not searching in this case. Otherwise, an invalid handle if it fails. Okay. So we have that. I'm just going to go to definition here. Whoops. Here. And down here. And we'll paste this guy in. Remove that. And essentially, it's going to wind up being 90% the same. We're probably going to wind up having some sort of internal static function that we call from both and just pass a parameter or something. But what we have to do, we do have to have this step where we create a K handle, right? So actually, no, we don't need this step because that's the searching one. Let's see. Shader create is going to be, all right, shader request info. So the difference between this one and above is this source text gets set to, let's see, should I, I'm going to take a copy of the string, I think, of the source string. That way I don't have to worry about the life cycle of it. So we'll say string duplicates shader config source. All right. So we're going to say load from config from string source, and we'll see how we generate that string source in a second. Okay, so we load this, pass off the request information. Create the shader. I think that's probably all we need to do. If K handle is invalid. So this error message is going to be wrong. Let's get rid of that. And actually, this is a K name, so we actually have to do K name string get, which means that is actually wrong. That's going to be wrong up here too. Okay. We're going to say shader blank from config source, so we know how it was loaded. Okay. So I think that's literally the only difference. And if it winds up being the only difference, we're just going to take all this logic, move it into a static function that we can just call internally, and then pass a NF check or something. All right. It seems way too simple, but I guess that is all we actually need to do. So, default material shaders. Standard material standard shader is going to be from source, right? We're going to have config source. It's going to be the difference there. And then we're going to have config source here, which is just equal to that, just so we have it, right? And now what we're going to do is we're actually going to generate this. So the way that this is going to work is we already actually have a serializer that will do this for us. We have a serializer that can read and write to this format. So all we actually really need to do is this ultimately becomes a shader asset. So all we need to do is create a shader asset in code, and then serialize that. We get our string, and then we could destroy that asset, right? And we can then take this string, plop it here, pass it on, and we're done. So what we're going to do is, I guess we'll do k asset shader, right? And we have our serialize method right there, right? So we're going to say shader, and we're going to call this mat standard shader. Yeah, that's good enough. All right. So matte standard shader has a few base properties, right? So its name is going to be this, right? So actually, what we can do here is we can actually just, technically it's already in the config source. Maybe we just do, nah, that's fine. We'll do, how do I, you know what? I'm going to split this out to different lines so I can use it more than once. Shader name is that, right? So we can use that, whoops, here. So that's going to be name, and then we pass that here, standard shader name, right? Okay. So base name, whoops, package name is going to be, in this case, it's going to be kname creates, and this is going to be runtime. All right, it's always going to be considered to be in the runtime package. Oops, base. So generation doesn't really matter, right? But I'm still going to invalidate it. Size, file watch ID. I don't think I need any of that stuff. Because I don't need that for serialization, so that's fine. We do need the type. So that's going to be shader. Base. ID and meta, I don't think we need any of that stuff either. So we can actually leave that stuff alone. Okay, so now we basically have to fill out all these other things. So essentially, we're going to go through all these properties and fill them out one by one. So I guess we don't have version anywhere in this, do we? Maybe it's under meta. There it is. Version, which actually source asset path tag count. Okay, so this is the only thing we should probably have to fill out. We do need to set the version of that. So let's do depth test. We want true for that. In fact, I think we can actually cheat here. So I think we could do this, and then do that. Supports wireframe, really isn't in there. Max groups. Oh, we have to do this. Okay. So this just needs to be changed to the actual enumeration. So call mode back is what we want for that. All right, so that's those properties there at the top. We also have, let's see, color right. So this does write to the color buffer, so that's true. That standard shader color read, it does not read from the color buffer, so that's false. Okay, so max draw IDs is going to be max. Do we have max material count? We have the text for it, but not anything defined. Have we defined the number of materials? Actually, I think that's a configuration property. State, config. Ah, there we go. Max material count. Okay. Actually, no, that's going to be max instance count. So we have that. We have also max groups is going to be max material count. So we no longer have to like have our configuration manually match up to this. We're just going to pull that straight from the data that we already have in the material system. Okay, topology of types, I guess, is going to be next. Oh, do we have stencil test and all that on here? No, we don't have stencil test. So stencil test is going to be false. I know that we're technically zeroing this out, right? But I'm trying to be explicit here. Stencil write is going to be false. We don't write to the stencil buffer there either. Let's actually group some of those things together. Same with the color stuff, right? So that's the buffer writes versus reads. Oops. Matte STD shader. Supports wireframe. We already have that in there. Stage count, call mode, base, step test. Okay, I think we have everything except for the collections like stages, attributes, and topology types and uniforms. So I guess we'll do them in this order, right? So topology types. And I believe this is a bit flag thing. Yes. So all we need for this is it's just triangle. Oh, that's triangle strip. No, that's triangle list is what that should be. The config file is actually wrong. So we're just going to have that equal to that. This should have been list, and I copied the wrong one here anyway. List bit. Okay. Let's see. Hello there. Is it still version 0.8 that you're developing? Yes. That's what we're working on. Yep. Let's have fun for the night. Thank you. Looking forward to future streams. Awesome, Technomancer. Thank you for coming. Appreciate it. All right. Thank you for the follow. Appreciate that. Welcome. All right. So that's the topology types. Stages. So stage counts for us is going to be 2. And then stages is just an array, right? So we're just going to do k alloc type C array. This is going to be k asset shader stage, and it's going to be stage count. And then we're going to say stages sub 0. First type is going to be, let's see, did we store this as a string? I forget. We do have shader stage. Yeah, okay. But these are both stored as strings. Okay. So shader stage vertex is the first one. And then we can do, let's just do this. So package name is going to be runtime. And source asset name is going to be this. And it's fine to hard code this because this shader is always going to be the same, right? So this is like an internally known shader. It's always going to be this way. So that's the first stage. Then this is the second stage, which is going to be the fragment. Same package name, same asset name, except it's going to say frag at the end. So that's that. And then attributes. So let's split this up a little bit. So attribute count. What do we have here? 1, 2, 3, 4, 5. That's 5. I'm actually going to take this and do attributes, and that is of type KSShader attribute. This is going to be attribute count, right? And so all that is in the attributes, so we'll do 0, and all we have is type in name, right? So type here is going to be attribute type. Oh, okay. What is this? What is this? Wrong button. Shader attribute type. Okay, I thought so. Attrib type. And that's going to be a vector 3. Whoops. Oh, it's float 32.3. Forgot about that. Thank you for the follow. Welcome. Let's see. Just out of statistical curiosity, I wonder how many lines your project contains. Well. Wait a minute. I think I need... There you go. That's exactly how many lines of code. Gotta love we get Linux utilities. Very quick way to get that. I'm not 100% sure it's accurate, because I'm pretty sure I don't have that much in comment lines, but maybe I do. But that's the idea. So it looks like we're actual code 72,000 lines. Try to document my code as best as possible. It's not always possible, but... Okay. Yeah, it's quite a lot. Okay, so we had type and name. So name, and that's just a string, so we can do in position, right? So we essentially just need to do this and copy these over. Actually, I wonder, you know what? I'm gonna cheat. I'll do that. And then standard shader attributes. I'll start at 1 and then put dot. And then do that. Oh, I didn't need to. Oh, I'm going to have to change the type for those. That's fine. Okay. So this is going to be 2, 3, and 4. And then this is going to be, let's see, another vector 3. So let's see, we have another. Actually, these are all vector types. So what I'm going to do Okay, so normal was vector 3, text scored is vector 2, in color is a vector 4. And then tangent was vector 3. Okay. So we have that. And then the only other thing is going to be uniforms. So this one's a little bit more strange. So we have a uniform count. I don't even know how many uniforms we actually have here. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and that number is drastically reduced, by the way, because you may or may not have noticed that I've pared this down, and we're actually going to use structures, and we're going to load whole structures of material data instead of all these little miscellaneous properties from one thing to the next. Anytime the shader is updated, we're just going to throw over all the data, because it's far more efficient to do that than to have a bunch of little copy operations, believe it or not. So we need to do this. And this is going to be uniforms. All right, and this is going to be KAsset shader uniform, and this is going to be, whoops, uniform count. Okay. And then I think ultimately what I'm going to do is I'm probably just going to go ahead and copy this again. And I'll have to just sort of reverse work this, right? Work through it, but so we're going to do per frame. Right, so I'm just going to comment that for a second. So that's per group. This is per draw. And then we don't need these individual things. Okay, so those are the per frame ones. These are the per group ones. And then there's just one per draw one, and then we don't need that. Okay, so what I can actually do in this case is go all the way down like this and do mat standard shader uniforms. And then we're going to just say, we'll say sub-0, right? And we'll just change it all the way down. And then dot, right? And we can, that is not what I wanted to do. Just get rid of these that we don't need. Okay. So these ones that are struct, we're just going to have to change to shader uniform, whoops, type struct. Okay. And then size is 388, so that's fine. So we put semicolons. I'm just going to actually go down and put semicolons at the end of all these and then fix the types in a second. Okay, so this is going to be shader uniform type texture 2D. Or I think it was going to be a texture 2D array. Yeah, it's a texture 2D array. And then, let's see, we have IBL cube textures. Whoops, we need that. And then this is going to be a texture cube, so shader uniform texture cube for that one. Wait a minute, it's an array. That should be that. Oh wait, no, it's not. It's not an array texture, it's a array of textures. Okay, so that's actually fine. Let me actually split these up a little bit here. Right, so this is going to be index 1. This is going to be index 2. This is going to be index 3, index 4, and this is going to be shader uniform type sampler. And this is also going to be sampler. And I think we have a couple more samplers down here. We have another one here. And I think this last one, no, that was it. Okay, so we have a couple more structs. Let's see. This one. Okay. And then split these up a little bit. Okay, so this is going to be index 5, 6, 7, and 8. And then this texture type is texture type 2D. And this is a array of textures, not a texture array. So this is going to be shader. Whoops. What did I do here? Shader uniform type texture 2D. Okay. All right. So that is all the uniforms. The only other thing, I think these all actually require a scope to be added to them, if I remember correctly, or a frequency rather. So this has to be shader frequency, update frequency rather, per frame. So I'm going to copy this and put it here for all of these. I'll obviously have to change the index in a second. So 4, 3, 2, 1. And then, actually, I'm just going to grab this one. Per group is going to have to be the same thing. So let's change this to group. So we need that one and this one. So this is index 6 and index 7. And then this last one down here, index 8, is draw, per draw. I think that is all the properties that are there that we need. We set array size where it's needed. Yep, okay. So that should be good. All right. So the next step of this, now that we have this, is we need to take this whole thing and serialize it. So we can take shader, shader serialize, pass it the address of mat std shader, and that returns to us. Actually, let me just take this. Our config source. Let's see, why is this bleating? Oh, it takes just a generic K asset. Okay, I just have to cold cast that. No big deal. Okay. Serialize. Okay, so our config source then gets passed through to our request. And now instead of loading this thing off disk, it's loaded from here. So we can actually control all of this stuff in code, which is actually where we're going to have a lot of this stuff anyways. So let's see, max groups. Didn't we have... We have this kind of hard-coded to 256. This is going to be... I thought we actually... Yeah, we did set that down here. It's just a copy pasta issue. Okay. So we have that. Once we serialize this, by the way, we can actually do away with this asset, right? So let's see. We have to actually manually destroy this, right? So what I'm going to do is I'm actually just going to take, I think the only thing that I don't think we duplicated any strings here. I think it's just these arrays we really need to worry about. So I'm just going to copy this section real quick and come down here. Destroy the temp asset, right? And we're going to do a k free type C array. And we need to take this, paste that there, and then remove this. We don't need this. So it's going to be stages. Then attributes is basically going to be the same thing. So actually, I'm just going to do kind of the same thing here. And then instead of allocating, we do free, right? And then one more, which is this. And then just for good measure, we're going to do a K0 memory on mat std shader, and that's going to be size of k asset shader. Perfect. Okay, so we don't leak that memory. And so now this should allow us to essentially load this based on actual properties that are in our material system, so that as we change those things and reconfigure those things, we don't have to keep changing this file also, so it matches up. So I'm actually going to do note this file is no longer required. Loaded directly in code in material system. And we're eventually going to delete this file, right? But until we get to that point, until we actually get to that point, we're not going to delete that. Okay, so create load the shader from the serialized source. Okay. And then set up as normal. So that's going to be our creation of our material standard shader, right? And it's still going to allow us to get all this stuff off disk that we need to get. So we're in good shape there. There are a couple of things that we're going to have to do in terms of actually binding the material and uploading that stuff to the GPU. I've got a lot of that work done for the standard shader, but we're going to have to pick that up next time because I just realized what time it is. Counting. Yep, exactly. Okay. So I'm trying to think if there's anything I needed to cover before I close for the night, but I don't think there is. All right, so that's going to do it for the stream tonight. I really appreciate you guys hanging out with me tonight, and we made some pretty good progress tonight, actually. We scratched some items off the list, which is nice. So I guess what I'll do, I'll go ahead and commit this too. So we're going to say work in progress, material system, loading, default shaders from code. I'll push this. Okay. All right, so let's find somebody to raid. And before we do that, or I guess as I'm looking, if you guys haven't followed me here on YouTube, I would really appreciate if you did. Just because I'm trying to grow the channel and inspire, hopefully, more people to get into game engine dev. So, you know, the more I grow the channel, the more people I can reach. Hopefully, the more people that I can get into doing this kind of stuff. So. Let's see who I can raid that's like loosely kind of developed. I'm getting tired. That's loosely related to development. Let's see. Kind of hoping I can find like a C programming stream or something similar. Looks like a lot of level design, which is not necessarily a bad thing, but... Oh, you know what? I need to switch categories here. All right. Let's see. I'm just scrolling through a list here to see if I can find something that looks interesting. Not a whole lot in the programming sphere tonight, actually. Unless you guys have a suggestion of who I could raid, if you guys are aware of somebody that maybe I'm not seeing in this list. It's a pretty long list. You know what? We'll just go with where did it go? Did he stop streaming? It was here just a second ago, I thought. Here we go. Let's see. Was he actually deving or is he just looking at YouTube videos? I'm not sure. Oh, there's a... Okay, all right. We are going to raid Hypnotic Games. So I'm not sure exactly what he's working on right now, but we can ask. But he's another game dev here on Twitch who's trying to grow his channel. So I like to support small channels likewise, you know, as we're a small channel here. I like to support other small channels. So we're going to raid him, see what he's up to. Thank you guys so much for being here. I appreciate you guys, and we will see you guys in the next stream. See ya.